My name is Bruce Berriman. I work at the NASA Exoplanet Science Institute, part of the Infrared Processing and Analysis Center on the Caltech campus. Today, though, I am speaking as the chair of the Exec Committee of the International Virtual Observatory Alliance, and I'll explain what that is in just a minute. Before I get into the technical discussion, I'd like to give special thanks to two of my colleagues who work on the IVOA, Simon Toole from Australia and Rafaela de Brusco from Harvard. They have both very generously allowed me to adapt some of their own material for this presentation. FAIR principles come into play in astronomy in what is known as the virtual observatory. And some of you are probably already familiar with this. Probably the best and most elegant definition of it that I know of comes from Pepe Fabiano at Harvard. It's a multi-wavelength digital sky that can be searched, visualized, and analyzed in new and innovative ways. So it's not an archive, it's not a repository of any kind, but rather it's an ecosystem of tools that are developed by discovering and accessing data in worldwide astronomy archives, and then fusing them and analyzing them. So the data in astronomy are actually distributed over 19 time zones. There are big archives in Australia, Japan, United States, Canada, Chile, South Africa, Europe, and so on. So we need to define standards that will enable all of these archives to operate together seamlessly so that this ecosystem of tools can be built. And the International Virtual Observatory Alliance, IVOA, is the body that has been set up precisely to define these standards. It's actually in business, has been in business for 20 years now, and it has 22 national VO member projects, and the US is one of those projects, and one intergovernment organization, which is the European Space Agency. The goal from the very outset, when the IVOA was founded in 2002, was to enable seamless interoperability of open data and services. So we were actually starting to implement FAIR principles before they were formalized as such, the paper by Wilkinson et al. In 2016. And so if there's one important message to take away from this talk is that implementing these standards in astronomy makes your data almost fair, not quite, but almost. And I will explain what I mean by that a little later on. But first, I'd like to give you two examples of the VO ecosystem in action. Since the VO is a worldwide project, I'll give you one example from the US and one from Europe. So from the US, the archives funded by NASA have implemented IVOA standards across distributed archives of heterogeneous data that cover 15 decades of frequency. And it's the first distributed implementation of standards over such a large scale. And you can, in fact, access all of these data from all of these missions through a common set of machine-based APIs. And they're very widely used in astronomy. In fact, there's on average across all of these data sets, there's an average of one query for them per second. The second example comes from Europe. It's a tool called ESA-SCI, and what it enables you to do is visualize the footprints of astronomical observations on the sky. You can pan and zoom across the sky, look at things in detail, and then if you want to, you can actually download these data to your desktop and start working with them. So those are just two examples that are both very successful. There are a number of others across the world too. So what does all this got to do with the IVOA? Well, the IVOA architecture from the beginning has actually had a lot of strong parallels with the FAIR framework, although the focus is to move metadata through the architecture rather than worry about the properties of the service or the data. I mean, that's our charter. I mentioned earlier that implementing IVOA standards goes a long way to meeting FAIR principles. Now, there are a few specifics that we don't do. In some cases, they're a bit out of scope for the IVOA. They're left to the data providers who are implementing the standards, or in some cases, we have just finished implementing and we haven't had complete take-up yet. So what I'd like to do is go through each of those FAIR principles that were outlined very nicely earlier on. It would be easiest in the short time I have to say where we don't implement things rather than when we do. But first, though, before I do that, let me give you a little sense of the architecture used in the IVOA. There is what we call, there is the IVOA core, which contains semantics, languages, query languages, data models, formats. That's the very heart of building VO services. We provide services for sharing at the bottom and using by end users, and also finding through registries of services. People register them when they're complete, and data access protocols that allow people to get data. So let me take you through all this, the FAIR principles. I almost said standards then. It's not strictly a standard, of course. And the items in blue are where we don't completely provide compliance. Now, the IDs that the IVOA provides are not citable. That's left up to the service provider, as is registering or indexing the metadata. We do not require that the data identified be returned. And in any case, service providers often have standards for citability that are given to them by their funders or by users. And so we leave it up to them to do that implementation. We're mainly accessible. The bit we don't do is when the data are no longer available. We don't have any rules or anything about that. That is left entirely up to the service provider. And again, they often have requirements on availability and longevity given to them by their funding agency. One thing we do is that we have a working group that monitors the services and provides what we call regular weather reports on availability. And if there's downtime or problems, we report them to the provider for them to respond and correct. Interoperable. Strictly, we meet all of those three conditions there. Strictly, we think we need a cross-referencing framework between data that can describe the same object or the same phenomena. That is in development right now and should be completed later this year. Reusability. We do not have any specification about licenses. This is up to the data provider, and again, they often have third-party requirements on what licenses they are expected to use. For our 1.2, we do have an IVOA provenance data model that was recently published. It took many years of effort and was published last year. Not that many providers implement it right now, but for many of them, it's actually a major effort for the coming year or two. So we hope that that is met in the next couple of years or so. Finally, the session is about AI. So I wanted to include something about AI and ML. Now, you can throw ML tools to FAIR compliant data sets, and you can extract a lot of the most elusive patterns. The next step, though, would be to build some intelligence into the ML agents and let them determine whether a particular type of data is useful for a particular question. For example, determine the best data to calculate or estimate redshifts of optical quasars above submeasured redshift. Or to be really ambitious, can you guess the best way to estimate the masses of supermassive black holes, given all these multi-wavelength data that are accessible? Now, at the moment, FAIR principles do not seem capable of helping with that. They do not contain enough semantic information. They need to be much richer than what's available right now. So we see the role of the IVOA in this is to complement the FAIR framework mechanisms and add domain-specific but machine interpretable meaning through semantics. And in fact, we have a working group, an interest group, that has been set up within the IVOA, whose job it is to investigate this very topic. And finally, if you're truly desperate for late night entertainment, I invite you to listen to a talk by Simon O'Toole that he gave in November 2021. It gives a much more detailed description of FAIR data in the IVOA than I've given here. And secondly, there's an IVOA architecture document which outlines the principles of how the IVOA goes about developing standards. And in fact, the architecture diagram that I showed you a little earlier on in the presentation is the first diagram in that document. So that is the end of my talk. Thank you all very much for listening, and I hope you found it interesting and useful.